So now that I'm done ranting, let's talk about test philosophy. A test is 25 multiple choice, 2 appetizers, and 6 problems. It is given over 1 hour and 15 minutes. A final is 50 multiple choice, which it kind of makes sense. Bring a green Scantron, those half sheet variety. The reason why there was one time I did 55 multiple choice, and to grade a 55 multiple choice Scantron, you actually have to flip the side and run it twice. I don't want to double my work, so 50 is the max as far as I'm concerned. There are actually, I'm sorry. Why did no one correct me for this? That seems like a really big test. A test is 1 appetizer and 3 problems. A final is 2 appetizers and 6 problems. And it's given over 3 hours. This is 100 points. This is 200 points. So effectively, I've doubled everything. The size of the test, the number of multiple choice, the number of appetizer or small problems, the number of big problems. The major difference is that I give you more than double for total time. SDS students, and there are not many of those, you'll meet your grader outside my office like last time. For everybody else, you're in here. The final is just some conventional problems, talking about the, looking over the number. I don't have the statistics for the test. I want to see that multiple choice so that I can either make a correction or something. But there's going to be a curve. I was not thrilled. It kind of, there were a lot of more 50s than I recall. There were a couple of 99s, a couple 95s, and then it kind of steadily slid down, and then once it hit to the 60s and 50s, it kind of bumped up. So there will be a curve for that, obviously. How much I won't know. For the test, or for the final, you're given an equation page, which you can see online. And then in this particular case, for the final, I gave you like a sheet of figures and plots and all sorts of stuff that you can refer to. So whenever it says figure 1, you go there and you take a look at it. So I'm going to need that. What I'm going to do is kind of like sketch out an outline for things that I think are going to be on it. One is vector addition. Eschenberg students know how to add vectors and do it back and forth quickly. You will get the usual A vector is this, B vector is that, find C, where C equals A plus B. I'm not interested in the resultant or the equilibrium, just the resultant. Polar notation, component notation, that's what I love. 2, motion. Probably 2D. Motion is what physics is. I mean, you got a lot of stuff happening in the world concerning motion. So you're gonna get one of those major problems, metaphysical certainty. Atwood's machine. it will either be energy or motion. Now, an Atwood's machine effectively is 1D motion, so probably it's going to be a 2D and an Atwood's machine. Energy or motion, I won't decide until this weekend. For collisions, energy could be dealt with motion. We did not do an inelastic collision in the test, so we'll definitely do one here. 5, rotation. Where alpha is not 0. We had Fish of Fury for test 2. So we're gonna have a moment of inertia and torque problem all in here, working with rotation. Probably there will be a buoyancy fluid problem. Let me tell you how I decide problems. It's a lot like when you plant a garden. Typically what I do is I plant about 5 appetizer seeds and 12 problem seeds, and I watch them grow. And I look at them and they poke out of the soil, and I look at it and go, that's a mutant, that's not working at all, and I pluck it out. So I come up with typically twice as many problems as necessary. And then I take a look at the ones that work well and the others that don't work well, and go with that. So I'm going to come up with a lot of topics today that could be on the test, but it may or may not be. The problem is I don't have an 8-hour final. I can't touch on everything, thank goodness. So a 3-hour final is all I got. Test 1 material, vector addition, 2D motion. Test in Atwood's machine. Test 2, collisions, energy, could be an Atwood's machine. The rotation, moment of inertia, torque. Torque bar. Perhaps. The torque bar problem in problem 2 really wasn't, the class didn't really bond that well with it. So it could be likely that it shows up again. Probably a little bit more of a conventional torque bar than the Harrier Jet, which is awesome. 8, oscillations. There will not be an Atwood string, but there could be plucked strings and stuff like that. Sound. Doppler shift, probably not. I'm not feeling it. Talk to me more on Friday if I'm feeling it. If you get oscillations in sound again, there may be more like an appetizer problem, or I could make it a hybrid problem and bring in multiple topics. And if you have multiple topics, then you're able to make a good problem. So what we'll do initially, so any questions about the general layout of the final, logistical stuff like that? Okay. This is the 213 final from December of last year, December of 2016. If we look at the problems, trying to think, best guess is I would take a look at that pendulum length value, and that, since I hand wrote that, I probably changed that value with the version. So I'm going to call this version 2. Number 1, which is the largest? It's D, yes. Block is resting on the table. You push down. What happens to the normal force? C, increase. Object in translational equilibrium means what? B, sum of the forces is equal to 0. Negative 2x hat meters is what in polar notation? C. Bo Wallace throws a football to Coach Freeze. There's no wind resistance. Which quantity changes? You would say E changes, vertical acceleration. Why would vertical acceleration change? What is it under the influence of? Gravity. Does gravity change? So why would it change? Exactly. So what is changing? Now, gravity affects in the vertical, so it's got to be vertical. A is a horizontal quantity, or A is a horizontal velocity. Horizontal velocities is just V naught x, because there's no horizontal gravity. A 2 kilogram mass rests on a flat surface. What is the normal force? Speak up. It's 20 newtons. 2 kilograms, it's mg. 2 times 10, 20. Circle of radius r has what circumference? Gotta be B. Basic geometric shapes will not be given to you. Circumference, volumes of the cylinder, cube, and sphere, surface areas of the volume, cube, and sphere, none of these will be given to you. Because you're a human, and my doctor still knew what a volume of a cylinder was. The units for coefficient of friction are, and I gotta look at it. Which one? It's A. Remember that inherently, coefficient of friction is nothing. It's unitless. So what you're looking for, since everything is dealing with newtons except for these two, those two are obviously not it. It has to be A, because kilogram meter per second squared is a newton. Newton divided by newton is nothing, or 1. So it's a unitless value. You drop an object. What is its initial acceleration immediately after your hand is no longer touching the object? D. The moment it is not in contact with anything, its acceleration is negative 10. A book rests on a table. You begin to lift the book up. The normal force, D, decrease. What are the units for velocity? E. Probably one of the things that will be, well, not probably, it will be tested. Know your units. Know your units. Know how to manipulate them. Know how to move from one to another. It will be tested. Nanometers to meters. 2 nanometers to meters. Nanometers is -9. Nano, 9. What I'm gonna do, all right, we're gonna play a game. So, nano, what's the next step after nano? 10 to the -9 is nano. What's 10 to the -6? Micro. 10 to the -3. Milli. 10 to the 3. Kilo. 10 to the 6. Mega. What's the letter for mega? Mega. Capital or lower? Capital. What do you use for milli? Lowercase m. Micro, what do you use? Mu. Capital mu or lowercase mu? Lower. Spell mu. Mu? It's not an onomatopoeia, it's not a sound. Spell it. M-U. Yes. Correctly stated, incorrectly attitude. M-U. Or you could say C-O-W. Now I accept it. After, so, kilo, mega, what's next? Giga. What letter? Capital G. What's the next? Tera. Think about this. Your or certain files, kilobits, kilobytes. Program, or, well, small programs, megabytes, or songs, megabytes. Big program, or programs, gigabytes. Hard drive space, terabytes. And then comes, anybody else who knows the next one? We just need to know it, we won't use it. Excellent. Oh, no, PETA. And then I talked to my student, I've said it before, Peta, Exa, Yada, I think it's after that. And there isn't anyone after Yada, and then someone proposed Hella. And then scientists are not funny, and they said no. What is the unit of frequency? Hertz. Radial acceleration is what? Points to the center of the circle. What are the units of linear momentum? C. What do you use? If I gave you 2 quantities to get momentum, what 2 quantities would you need? Mass and velocity. Mass kilograms, velocities meters per second. You can sit there and figure it out on your own to get the units. Inelastic collisions conserve what? B, only momentum. Now I understand in the world they talk about the energy of the universe. The energy that we're talking about in this case is mechanical energy. Inelastic collisions do not conserve mechanical energy, which we will just say as energy. Hold on, what? 14. Radial acceleration is v squared over r. When you have say like you had a ball at the end of a string. Over there, it's moving in that direction. Oh. Over here, It's moving in this direction. Over there, it's moving in that direction. And over here, it's moving in this direction. What can you say about an object that has a changing velocity? If it has a changing velocity, it has an acceleration. Those acceleration vectors are radial acceleration vectors, and they always point inwards. Otherwise, the ball would move in a different direction. So the radial acceleration is always pointing inwards, and the radial acceleration as a magnitude is v squared over r. You will not get an elastic collision as a problem. You will get elastic collisions as multiple choice. Circle rotates n times in t seconds. What is the frequency? E, correct. Conservation of linear momentum is what? D. P initial is equal to P final. The frequency is 2 hertz. The angular velocity is what? Now, 2 pi f is equal to omega. So if it's 2 hertz, it's 2 pi times f. 2 pi times 2 is 4 pi. So B. Inverse of frequency. Period. B. Elastic collisions do what? Conserve what? C. Energy and momentum. An Atwood's machine has friction. What is the ratio of E start divided by E end? It has friction. It will be E. If there is friction, E end will be less than E start. So it has to be E. So a rocket spins a disc up from rest. Which value is constant? D, alpha. So the rocket is putting out a constant force. Sum of the torques is equal to I alpha, or torque equals I alpha. Torque is equal to the force times radius, so FR equals I alpha. The force of the rocket is constant, so alpha must be constant as well. An Atwood's machine has no friction. What is the ratio E start divided by E end? It is E1. At the node of a vibrating string, which of the following is true? D, it does not move up or down. Resonating half pipe. Third harmonic is same as the what? D, first overtone. Pressure, gauge pressure reads 2 atmospheres. What's the total pressure? It's 3 atmospheres or E. Number 28, among my more favorite multiple choice. Cubic meter of aluminum and a cubic meter of steel rest at the bottom of the lake. Which has the greater buoyant force? B, they have the same buoyant force. Buoyant force is fluid of displacement, density, water, volume of displacement. They're both 1 cubic meter times gravity. They're on the same planet. So the buoyant force should be identical. What is the equation for frequency of sound heard by a source moving towards an observer? E. Moving source, parentheses are on the bottom. Moving source towards, F herd has to be higher. To get higher, the denominator has to be smaller. Object is negatively buoyant. Which of the following is true? B. Unit of frequency, unit for frequency is what? C, hertz. 400 hertz, first harmonic, tighten the string. Which one is an allowable frequency? B, 800. A1V, that equation is what? B, equation of continuity. If I take A and V and multiply by T, what do I get? Volume. A is cubic meters, velocity is meters per second, time is in seconds, and I get meters cubed, so volume. The N for a third overtone for a string is 4, or E. Neutrally buoyant, which is true? C. Spring pendulum has a period of 2 seconds. You quadruple the mass, the new period is A4. Figure 1. So this is kind of a units question. Figure 1, which is momentum? 4. Which is angular momentum? 5. Angular momentum is I omega. I kilograms meters squared, omega inverse seconds. Using figure 1, which is a Newton? Oop. All right, now that one's obviously not it. There had to be editing going on. Which one is a Newton? Now, Newton's force times acceleration. Force, kilograms. Wait, Newton's. Yeah, it's mass times acceleration. Mass, acceleration, so it's 1. Which one is a joule? 2. Work is force times distance, or a Newton meter, or Newton's meter squared second, or kilograms meter squared second squared. Figure 2. Which one is the first overtone? It's 2. So this one would be D. In figure 2, which one has an equal number of nodes and antinodes? None of the above, D. Figure 2, which one is the third overtone? 4.
What was the lettering for
D. Okay, 44. Using figure 3, if 1 is velocity, which one is acceleration? It's 8, or B. Velocity, what's the slope of velocity? 0. A is dv dt, the change in velocity. So effectively, acceleration would be the slope of this, which is 0. If 1 is acceleration, which one is position? 9. We're dealing with the standard parabola. Using figure 3, if 9 is position, oh, well, this is dumb. If 9 is position, which is acceleration? Should be 1. What happens is, I can tell you what I did with this. Students were complaining about the finals. They were looking at the finals from earlier semesters, and they were seeing that sometimes a final has a greater fraction of multiple choice from test 1 than test 2 or test 3. And they wanted an even distribution. So what I did is I wrote basically 3 spreadsheets to sort through everything. And for like test 1 material, there would be 50 multiple choice, and then I would pick 17. Sometimes it got lucky and people lucked out. If figure 3 is position, which is velocity? If figure 3 is position, which is velocity? So the velocity, its slope is up, so it has a positive slope. But the slope is going to 0. This has a positive value and it goes to 0. So it's 6, or A. Using figure 4, what is Kennan crossed with Brevard? Lyceum. Using figure, or A. Using figure 4, what is Martindale crossed with Vaught? Lewis. Using figure 4, what is Brevard versus Lyceum? Kennan. And that is a sample find. So what we're going to do, just as advice for, I get a lot of people who go, well, what do I need to take a look at? I would look at the Tuesday, Thursday, Friday review sessions. Go over those videos. These videos will be up tonight. And then I want you to go through the test 1, test 2, test 3 review sessions. And then I would say go through the tutorials. And only after, if you've mastered all 3, then I would say go through the lectures. Because these review sessions that we're doing this week are condensed versions of the class. The tests are condensed versions of the class of that specific portion of the semester. So it begins to, the further down you go, the more stuff you have to cover. All right, let's do this. Simple pendulum of length 2 meters. Stop. Length equals 2. It's a simple pendulum. Period. Equals 2 pi square root L over G. Has a 20 kilogram mass at the end. What is the ratio of T moon, or I'm sorry, T moon under T earth? Well, the mass is irrelevant. It's a simple pendulum. Simple pendulums are mass independent, so I'm not going to write that down. So T earth, 2 pi L over G. It also upset my students that I didn't give them the link, or I did, well, no, it didn't bother them at all. 2 pi square root L over G prime. The 2 pi's cancel, the L cancels, and I'm left with the square root of G prime over G. G prime is the denominator of the denominator, so it gets kicked up. G prime is 10 over 6. G is 10. Square root 1/6. Done. Appetizer number 2, sound. What is the fundamental frequency, first overtone, and second overtone of the following half pipe? Velocity of sound is 350. The frequencies are NV over 4L, where N is equal to 1, 3, and 5. Half pipes do not have even harmonics. This is the fundamental first overtone and second overtone. So what you do really is you find F1, which is just 350 over 4 times 0.5. And then F3 is 3 times F1, and F5 is 5 times F1. So then you plug all that in. Give the resultant of A plus B, A, 6 meters at 270. Once again, we're testing our knowledge of instant conversion vectors. 6 meters at 270 is what? -6 y hat. Correct. 270 is straight down. So -6 y hat. Now 4 meters at 110 is B. I gotta break this thing down into components. 110 is a what quadrant vector? Second. You draw a generic second quadrant vector . If the absolute angle is 110, what's my reference angle? 70. Because 110 plus 70 is 180. BY is equal to B sine theta R. BX is B cosine theta R. So this is 4 sine 70, 4 cosine 70. And that will give me 3.76 1.37. It's a second quadrant vector, which means which component will be negative in this expression? It will be the x. So it is negative negative 1.37 x hat plus 3.76 y hat. So that's my A, that's my B. The C vector in component is negative 1.37 x hat minus 2.24 y hat. That's the resultant in component notation. What quadrant is that vector? 3. Both components are negative. You draw a generic third quadrant vector. Cx, Cy, theta r. Now C is Cx hat, or 3Cx squared plus Cy squared, square root. 1.37 squared plus 2.24 squared. I don't care about signs because everything is squared and it goes away. .63 meters. That's the magnitude of C. Theta r is your reference angle. It is always the inverse tan of Cy over Cx. Inverse tan of Cy, we're only using magnitudes. Cy is 2.24 and Cx is 1.37. .5 degrees. That is the reference angle of the vector. If 58.5 is the reference angle, what is the absolute angle for this? What did you do? Added 180 to it. 238.5. Because that is the absolute angle. 58.5 plus 180, or 238.5 degrees. When you add -6 to positive 3.76, you get negative 2.24. A is -6y hat. B is that. You add your x's and y's to y's. Where did I what? -6y hat is an instant conversion vector from 6 meters at 270. 270 is pointed straight down. So that's where I get -6y hat. That's a vector addition problem. Granted, I did it fast, so it's not real pretty, but it shows the conventional steps. Add them, break them, recombine. Number 2, like the final, or like the tests, the final will not have quadratic solutions in it, or require a knowledge of it. That's math, that's not physics. So I am looking for the initial velocity and angle at launch. The time is 10 seconds. It's launched off a 200-meter cliff at an angle like that. An initial velocity. 10 seconds later, it lands 100 meters away from the cliff. What is the initial velocity and what is the angle? It's a two-dimensional motion problem. Boom, pull out my favorite equations. X equals x naught plus v naught x t. There is no horizontal acceleration, so there will be no 1/2 at squared. Y equals y naught plus v naught y t plus 1/2 at squared. Apply the zeros first. Or choose the origin, pick lower left. X naught is 0. This thing lands over here, Y final is 0. Since it's going up at an angle, I get this. So X is V naught cosine theta t. 0 equals Y naught plus V naught sine theta t plus 1/2 AT squared. And I get all of this. Identify knowns and unknowns. Green and below is a known, red and above is an unknown. So my unknowns are X, Y naught, T, A is -10, because in this coordinate system, up is positive and right is positive. I'm looking for theta and V naught. So those are my unknowns. This is a 2 equation, 2 unknown problem. And you die a little more inside. It's like that one person on Twitter. You do a substitution. What I would do is I would substitute V naught out. So V naught is X over T cosine theta. Plug that into here. 0 equals Y naught plus X over T cosine theta T plus 1/2 AT squared. Oh, and I forgot there's a sine theta. Those T's cancel. Simplifying, 0 equals Y naught plus X tan theta. Sine over cosine is tan. Plus 1/2 AT squared. I've got everything except for theta. So minus Y naught minus 1/2 AT squared is equal to X tan theta minus Y naught plus 1/2 AT squared divided by X is equal to tan, and theta is inverse tan minus Y naught plus 1/2 AT squared over X. You do that and you get theta. You get theta, you plug in here, you get V naught, done.
Shouldn't that be negative Y naught minus?
Oh, correct. Parentheses. You drop a sign and the whole thing blows up.
So that turns into inverse tangent, the absolute tangent.
Yeah, you take the inverse tangent, you get a theta out of it. You plug it into the cosine right here and you get a V naught. The rest is just plugging and chugging.
Why is Y 0?
Y final is 0 because, where did I pick the origin? Where do I typically pick the origin? The lower left corner. So in the lower left corner, anything on that horizontal axis, Y is equal to 0. So it lands, where does the ball land? On the horizontal axis. So Y final is equal to 0. Y initial is at the top of the cliff. That's why. Had I chosen Y naught, or had I chosen the origin to be the launch point, then Y naught and X naught would be 0, and Y final would be negative 200. So it all depends on your choice of location. Last problem before we break. Given the conditions shown below, what is the final velocity of the system the moment before impact? It is purposefully not given to you how I want you to solve this. What is the most efficient way of solving an Atwood's machine problem if I'm only looking for final velocity? You attack it with energy. The energy problems for final velocity are the easiest way to get your answer. Now, boo friction. The energy initial minus the work removed through friction, energy removed through friction, is energy final. At the beginning of the motion, the only thing that is going on, no velocity, object hanging over a cliff. So the only thing left in there is M2GL. That's the only potential energy. Because the first object did not rise or fall, that energy is not there. Now, work removed through friction, you know how much I love going through this. Sum of the forces in Y is equal to 0, which is normal force minus M1G. Normal force is equal to M1G, so friction force is mu sub K M1G, because friction force is normal force times mu sub K. So the work, which is force times distance, is mu sub K M1G capital L. Because if M2 falls a distance L, M1 moves over a distance L. So this is minus mu sub K M1G capital L. At the end of the motion, the masses, there is no potential energy left, but the masses are moving. If the masses are moving, it's 1/2 M1 plus M2 V squared. And so that's the setup of the equation. Now, one of the things that we're going to have to pay attention to is, well, it's one of the major things. What does Dr. Eschenberg like to do during his tests? One is, you're going to do a 2-equation, 2 unknown problem. It's going to happen. It could be in all sorts of problems. The other thing that he likes to do is definitely, he doesn't like to do quadratic solutions to problems. So he's going to have them all set up so that you don't have to do it. The third thing is, he's going to do acute substitution. I specifically said in the problem that M1 is unknown. All I did was give you the ratio of M1 to M2. So what you do is you substitute 3M1 GL minus mu sub K M1 GL equals 1/2 M1 plus 3M1 V squared. So this becomes M1 GL 3 minus mu sub K equals 4M1 over 2 V squared. I did not give you the mass M1 because it is unnecessary. So GL 3 minus mu sub K is V squared over 2. So 2GL 3 minus mu sub K is equal to V squared, or square root of 2GL 3 minus mu sub K is equal to V. Whoa, what happened? 4 over 2 became, yeah, true. 4 over 2 became 2. Therefore, that is I can get cute and go -1, and so that fixes it. I forgot to move it over. And so now all you do is plug and chug. And so that's all we can really do. What we're gonna do on Thursday is we'll attack the test questions directly without having to waste time hand out tests and do the multiple choice and talk about finals. All we'll do are test problems from this semester on Thursday. So bring your tests and we'll go over that. Thank you.